Hi everyone! This is the third video of multi-step equations, and once again we're going to use our steps to get through this equation. So the first step, as you know, is to apply the distributive property. So we can do that here. So I'm also going to draw that vertical line through my equal sign to keep the two sides of my equation straight, like so. So it's negative 5y plus 30 equals 5 times 3 is 15, so we get 15y. 5 times negative 2 is negative 10, so we have 15y minus 10 minus 12y. Next, we're asked to combine like terms. Again, you can only do that when your like terms are on the same side of your equation. So if we look over here, we see that we have a 15y and a minus 12y, so we can combine those. 15 minus 12 is 3, so we have a positive 3y minus 10. And again, we'll just bring down everything else that we didn't change from the equation. Okay, now we want to move all the variables to one side of the equation. So remember my hint from the last video, I want to do this in such a way, if possible, right, it's not always possible, but if I can, I want to make the coefficient of my variable positive. So notice that if I choose to add 5y to both sides, instead of choosing to subtract 3y from both sides, that will give me 3y plus 5y, that gives me an 8y, and that gives me that positive coefficient that, again, just reduces the probability that I'm going to make a sign error, because, you know, we're all human and we make mistakes. Okay, so then, right, it says to move all constants to the other side of the equation, and remember, other side means the side that the variable is not on. So, again, my hint is to move terms away from the variable, not towards the variable. So that means that since I have this minus 10 right here next to the 8y, I want to get rid of him. He needs to go away because my goal is always, always, always to isolate the variable, to get the variable all by itself on one side of the equation. So if I add 10 to both sides, I get 40 equals 8y. So then, last but not least, we isolate the variable. So I have 8 times y. I undo multiplication by dividing both sides by 8. So we get y equals 5. Okay? As always, you can go back and check your work. Just for the sake of time, because this is my 8th example, I'm not going to demonstrate that in this video. But again, I encourage you guys to take some time, go back, put 5 back into the original equation, and prove to yourself that that is the solution. Let's keep going. Number 9 is, I'm going to put a star by it because there's a little tricky part in here. So please make sure you're putting this into your notes and watching very carefully, because there is a part of this question that a lot of people might trip over and get wrong. So let's go ahead and get started. It says apply the distributive property. So this is exactly what I was talking about. So you see that we have parentheses, right? So my question to you is, what number am I distributing? It's just a negative sign, as you can see, with no number next to it. Well, if I had to put a number right here, what could I write there? What if I put a 1 here? So what's really getting distributed is a negative 1. So I have a negative 1 times 4, and I have a negative 1 times a negative 2. So first I'm going to bring down the rest of the equation. So let's see what happens to the two terms inside the parentheses. So what's going to happen is that my 4x, when I'm multiplied by negative 1, becomes negative. But let's look at what happens to that negative 2. Negative 1 times negative 2 is a positive 2. Okay, so that's the part. Changing the sign of the second term in those parentheses, that's where most people just get tripped up and forget to do that step. Okay, so please be careful as you do these problems. And again, anytime you see just a minus sign outside of the parentheses, I encourage you to do what I just did, which is to put that 1 there and to show that you're distributing, you're multiplying everything by negative 1. So everything, every term in those parentheses, not just the first term, is going to change its sign. All right, let's combine our like terms. So 7x minus 4x is 3x. So we get 3x plus 2 equals 3x plus 11. Okay, that's interesting. So now we're going to move all of our variables to one side of the equation. So I am going to subtract 3x from both sides. I'm kind of running out of room, so I'm going to have to move over a little bit here. Also, I forgot to draw my line here. Sorry about that. So I end up with something that says that 2 is equal to 11. That's interesting. Is 2 equal to 11? It's not, right? This is a statement that is inherently mathematically false. So what does that mean? What do I do? What's the answer? Well, that means that this whole equation actually doesn't have a solution. There isn't any value of the variable that's going to make 2 equal to 11. It's just not possible. So if there isn't a solution, what's our final answer? Well, our final answer is simply no solution. There is no solution to this equation. There is no value of x that can make 2 equals 11 true, right? That's just never going to be, that's never going to work. 2 and 11 are completely different numbers. It's never going to happen. So that just means that this equation doesn't have a solution. So that's our final answer. Let's look at this next example. So the first thing we want to do, as always, is to apply the distributive property. So let me draw my vertical line here. So 4 times 3x is 12x. 4 times negative 8 is minus 32. Then bring everything else down. Okay, so then we need to combine like terms. On the left-hand side, we don't have any like terms. 12x minus 32. 7x plus 5x, that is 12x. So you might notice at this point, we have something that is equal to itself. So at this point, you might realize that doesn't really give us enough information. But just for the sake of argument, let's just keep going. So let's say that we need to move all variables to one side of the equation. So I'm going to subtract 12x from both sides. Okay, so that gives me negative 32 is equal to negative 32. If I wanted to, I could keep going and add 32 to both sides, and I would get something that says 0 is equal to 0. Now, obviously, this is true, but you might notice, where is the variable? What happens to my variable? There is, in fact, no variable in this equation. He's all gone. Okay, so sometimes students get to this point and they get negative 32 equals negative 32, or they say 0 equals 0, and they say erroneously that x equals 0. But that's not what this is saying. X is not equal to 0. It's saying that 0 is equal to 0. That's like me saying, hey, you are yourself. That's really redundant. It's true, but it's kind of an unnecessary thing to say. Okay, 0 is always going to be equal to itself, right? This is always true for any value of x, right? It doesn't matter. Right? X could be 519. 0 is still equal to 0. X could be negative 2. 0 is still equal to 0. Right? This doesn't have any information. This whole equation has 0 information about what x is. It doesn't really tell me anything about x. So what do we do? Well, if this statement is always true for any value of x, then literally x could be any value, right? So we say that there are infinite solutions to this problem. Literally, x could be any real number. Sometimes in certain math classes, you might say that x is all real numbers. You might see that. If you want to get really fancy, you can use element notation. So this says x is any element in the set of all real numbers. That's another way to write your answer. All of these are valid. You could also, there's a whole bunch of different ways to express it. But in this class, specifically, I'm just looking for the answer that there are infinite solutions. So this right here, this is what I'm looking for. So I would, if you get something that where a number is equal to itself, I want you to write that you have infinite solutions.